You need to hear this if you're a GE aspirant. Tautomerism made easy, just for you. Let's dive into the fascinating world of tautomerism, a concept that can seem tricky at first but is actually quite simple once you break it down. Tautomerism is like a chemical magic trick. Imagine a molecule that can switch forms, almost like a shapeshifter in a science fiction movie. This transformation is not just a visual change but involves a rearrangement of atoms within the molecule, just like a superhero changing costumes. In organic chemistry, this usually happens between two forms called tautomers. These tautomers are essentially the same molecule, but with a slight difference in the position of certain atoms, usually a proton and a double bond. These tautomers differ mainly by the position of a proton and a double bond. A classic example is keto-enol tautomerism. In the keto form we have a carbonyl group, that's a carbon double bonded to oxygen. In the enol form a hydrogen shifts, moving from one atom to another, and this shift changes the entire structure of the molecule, turning it into an alcohol with a double bond next door. This shift is not just a minor tweak, it can significantly alter the molecule's properties and how it reacts with other substances. For instance, the keto form might be more stable in one environment, while the enol form could be more reactive in another. Why is this important? These shifts can change the properties and reactivity of the molecule. Think of it like how Clark Kent and Superman have different abilities, but are essentially the same person. In the same way, tautomers can have different chemical behaviors while being the same molecule at their core, but are essentially the same person. This duality is crucial in many chemical reactions, especially in biological systems where enzymes might prefer one form over the other. Understanding tautomerism can give you a deeper insight into how molecules interact in different environments. For GE, remember, tautomerism usually occurs in compounds with hydrogen atoms next to a carbonyl group. Also, these shifts can affect reactions and stability. This means that the position of a single hydrogen atom can determine whether a molecule is reactive or stable, acidic or basic, and even how it smells or tastes. So next time you see a molecule swapping forms, you'll know it's just flexing its tautomerism skills. For example, in acetone, the keto form is more stable, but in phenol, the enol form is more stable. Keep studying and ace that G. Remember, understanding these small shifts can make a big difference in your grasp of organic chemistry. So keep practicing, stay curious, and you'll master tautomerism in no time.